Welcome back, students. Under Algebra Number Theory, we are in Unit 2, Finite Fields and Polynomials. In this lecture, we'll be extending the division algorithm idea. So in the previous lecture, lecture number 3, I had introduced what is division algorithm and who had found out. And so, I guess everybody remembers the division algorithm. So let's get on to the presentation. So here a few problems are to be discussed. So consider f of x is equal to 3x power 4 plus x cube plus 2x square plus 1 and g of x as x cube plus 4x plus 2 in z5 of x. Find the q of x and r of x where f of x is divided by g of x. So in this problem they had mentioned that f of x is divided by g of x. If it is not mentioned, so the first thing you have to do is you have to compare the two polynomials and its degree. So the highest degree polynomial should be used as your dividend. Okay. And the lowest degree polynomial should be used as your divisor. This is the basic condition. And then you can perform the polynomial division step by step. And here we have some restriction. What is the restriction? Z5 of x. So we have to consider Z5 of x. It's a field. So you know what are the elements inside that particular set. So Z5 in the sense, how will I write it? I will be writing it as 0, 1, 2, 3, 4, etc. up to 5. Sorry, up to 4. So there are totally 5 elements in that particular set. Now, how can a polynomial division be done under modulo concept? So the most important thing is you perform the polynomial division as always how you do from your childhood days, etc. Same thing, you're going to do it. But only thing is you have to keep a check on the coefficients of the variables and even the constant term. And you should see that all the coefficients of that particular division after dividing, whatever it may be, that should be from the set only, not from outside the set. So it should contain 0, 1, 2, 3 and 4, but not more than 4. And it should also not contain negative values. Is that clear? So now we are going to perform the polynomial division under modulo 5. So let's start. So as I told you, the highest degree term should be used as your dividend. That was 3x power 4 plus 3x cube plus 2x square plus 1. And the lowest degree term, that is x square plus 4x plus 2, is used as your g of x. Now we are going to divide the polynomials or the one dividend polynomial by the divisor polynomial. So what is the first term in the polynomial? 3x power 4. Now take 3x power 4 and divide it over x square. So what is my answer? 3x square I'm getting. So write the 3x square on my quotient term. So take 3x square and multiply the entire divisor term. So if I'm going to multiply each and every term in the divisor, I will be getting 3x power 4. That is the first term. Now I want to check whether this 3x power 4 can be accepted or can be written like that itself, or should I change it? So if I want to check, my coefficient of that x power 4 is 3. Is 3 allowed in the modulo set of 5? Yes, it is. So I will accept 3x power 4 and proceed to the next term. Now when I multiply the second term, I am getting 12x cube. Is 12 accepted in this particular modulo division? No, it is not. So what should I do? I should divide this 12 by 5. So if I am going to divide this 12 by 5, what is my remainder? The remainder is 2. So I will write the remainder. So make sure the coefficients of the variables after multiplication should be from the set. And next term, 3x square into 2 will give you 6x square. Is 6 allowed? Definitely not. So again 6 has to be divided over 5 and your remainder is 1. So I'm writing 1 here. So now multiplication process over, change the sign, cancel out 3x power 4 and minus sign here. If I'm going to subtract, I'll be getting minus 1x cube. Remember, what am I getting? Minus 1x cube. And if I'm going to subtract here, I'll be getting plus 1x cube, x square. Plus 1x square is accepted. 1 is there inside the set, but minus 1x cube is not there in the set. So what should I do? I should see the what short of 5 it is. So minus 1 in the sense I should convert it into a positive number. So if I'm going to find the remainder, minus is there, so I'm going to add it up. So I'll be getting answer as 4. So that's why I had written 4 here. 4x cube plus x square, and bring down this 1 from there. So now again take this 4x cube divided over x square. I'll be landing up with 4x. Take 4x multiplied with this divisor of with each and every term. So I'll be getting 4x cube plus 4 into 4 will give you 16x square. 16 is terribly not allowed here. So 16, when I divide it by 5, my remainder is 1. So I use 1 here. And then 4x into 2, you'll be getting 8x. 8x is also not allowed. Divided by 5, my remainder is 3. So writing the remainder. Now change the sign, cancelling minus minus and plus 4x cube. Negative here, 0, and here minus 3x and plus 1. So is minus 3x accepted? Definitely not. So minus 3 have to be, since it's a negative value, you got to add that 5 there. So if I'm going to add, my remainder is 2. So 2x plus 1 is my remainder. 3x square plus 4x is my quotient. And now I'm going to apply the division algorithm. Now hence the quotient is q of x is equal to 3x square plus 4x, and the remainder is r of x is equal to 2x plus 1. Therefore by division algorithm, dividend is equal to quotient into divisor plus the remainder. Therefore substitute each polynomial in its position, and hence the result. So we move on to the second problem. If f of x is equal to 3x square plus 4x plus 2 and g of x is equal to 6x power 4 plus 4x cube plus 5x square plus 3x plus 1 are the polynomials in Z7, find the quotient and the remainder polynomials. So you could see that, compare these two polynomials, and you could see that g of x has a greater degree than f of x. So automatically g of x will be used as your dividend and f of x should be used as your divisor. Now under Z7, what are the elements in Z7? 0, 1, 2, 3, 4, 5 and 6. Now you are going to find the quotient and the remainder under the modulo division Z7. So you perform the long division as always. Okay, now we'll perform the division now. So first let's take the highest power. As I told you, 6x power 4 plus 4x cube plus 5x square plus 3x plus 1. And 3x square plus 4x plus 2 as your divisor. Right. So take the first term 6x power 4 and 3x square, divide it over the other, and you will be getting the answer as 2x square. So now take 2x square and multiply with each and every term of your divisor. So you will be getting 6x power 4. Once after multiplication, kindly check whether the coefficients are in the particular modulo set. If not, you have to divide. Right. 6x power 4. And then 2x square into 4x will give you 8x cube. 8 is not allowed. So 8 is divided by 7 and the remainder is 1. And next 2x square into 2 will give you 4x square. So that is allowed. So now change the sign, cancel it out. Change the sign, 3x cube. Change the sign, you get x square allowed. And bring out this 3x down. And now take 3x square divided by 3x square. Sorry, 3x cube divided over 3x square. 3 and 3 will get cancelled and x and x will get cancelled. You have remaining x. So take the x here, multiply it by each and every term of the divisor. I'm landing up with 3x cube plus 4x square plus 2x. All the coefficients are accepted. Change the sign, cancel out the x cube term. And now if I'm going to change the sign, I'll be landing up with minus 3x square. Clear? And here if I'm going to change the sign, I'll be landing up with x. So since I got minus 3x square, right, what should I do? Minus 3 is not included in the set, so I will be adding 7 to it, and my answer is 4. So I'll write it 4 here. So 4x square plus x plus 1. Now again I have to perform the division because the power of the remainder and the power of the divisor are equal. I will stop only when the degree of the remainder is less than the degree of the divisor. Then only I can stop, or unless I get 0. Now both the powers are equal, so I have to proceed further. Now let me take 4x square divided over 3x square. If I'm going to divide 4x square over 3x square, what am I arriving at? It is like a fraction, which is not allowed there. So what does it actually mean? So 4 should be treated as the remainder when a number was divided by 3 under modulo 7. Okay. So now what is the number? You have to find out that particular number. Okay. When divided by 7 gives you the remainder 4. Can you tell me which number it is? Again I'm repeating. You have to get the number, right? When it is divided by 7, the remainder is 4. Which number is this? So the number is 18. So 18 only will yield you the remainder as 4 when divided by 7, because 7 twos are 14 and the remainder is 4. So the actual number is 18. So they had written the remainder. So we have to choose a number in such that the numerator becomes the remainder of that particular number. So 18x square. So you have to imagine it is 18x square and divide that 18x square by 3x square. So then it will be perfectly divisible. So 18x square over 3x square will be 6. So write down 6 in the quotient term. Take the 6 and multiply to each and every term in the divisor term. You will be getting 18x square. Again 18 is not allowed. So again you have to divide. The remainder is 4. Plus 24x. 24 is strictly not allowed. Divided by 7. Remainder is 3x. Again 6 into 2 is 12. 12 is also not allowed. Under dividing 7, the remainder is 5. Now changing the sign, 4x square and 4x square will get cancelled. So minus 3x is there and plus x. So it's going to be answer is minus 2x, which is not allowed. Minus 2 again. Add up with 7 since it carries a negative value. The remainder is 5. So 5 is accepted. So write 5x. And here I am getting minus 4. So minus 4 is also not accepted. Add with 7 and remainder is 3. So the remainder is of a lower degree of your divisor. So we can stop the process. So the remainder is 5x plus 3. The quotient term is 2x square plus x plus 6. The divisor term is this and the dividend term is this. Now let's go ahead with the conclusion. Hence the quotient q of x, hence the remainder r of x, and therefore by division algorithm, dividend is equal to quotient into divisor plus the remainder. Substitute each and every polynomial in that particular position, and hence the problem ends. Hope you understood. Thanks for watching. Let's continue in the next lecture.